Section 13.2, factoring trinomials in the form of x squared plus bx plus c. Okay, let's jump in here. We're going to factor trinomials with a leading coefficient of 1. Remember, the leading coefficient is this guy right here. Okay, this is how come we put these things in descending order. This is how we put the largest degree in the front, and then we go descend from there, and then we also look for that leading coefficient. Factor trinomials by first factoring out a common monomial factor. Okay, kept one of these just as how they had it. Okay, we're going to factor x squared plus 8x plus 12. Okay, what's going to happen here is this. Get out the red pen here. We're looking for the factors of this guy right here. Okay, so right here, there they are. It has three factors. We got 1 times 12, okay, 2 times 6, and 3 times 4. That's the first step, okay? Find your factors, okay? Then what we're going to do is look at these factors, and then we're going to add them up, okay? So notice 1 times 12 is 12. Then 1 plus 12 is 13, okay? Why do we want this? Because we're trying to create this guy right there. That's what we're looking for, which is I just don't think that they're really they really hit on too hard on this one. So look, we're looking for this guy. Okay, so notice we have factors of 12. 1 times 12, 2 times 6. Notice it's got 2 and a 6. 2 plus 6 is 8. Okay, when we come to the next page, this is how this works. Since we've got this x squared and we got a leading coefficient of 1, you can only do this when you have a leading coefficient of 1, okay? You can put this as, just like they had here, we put 2 parentheses, and an x will go into this one, and x will go into this one, okay? Then notice that we had those factors. Let's go back over here. We had these positive factors of 2 and 6. Notice that is a positive 2 there, okay? Well, then you put the plus 2 and the plus 6, and you're all done. Okay. Now what they're saying here is, note, if the middle term had been negative x, then we would have wanted pairs of negative integer factors to find the sum of negative 8. In other words, we would have found that x minus 2 and x minus 6. What they're saying is this. Notice that here your factors were 2 times 6 equals 12. But this guy right here is a negative number. Well, 2 plus 6 is only ever going to equal 8. But negative 2, okay, plus negative 6 is going to equal negative 8. But also you got to look at it this way. Negative 2 times negative 6 does equal positive 12. We still have to be able to create that positive number right there. Okay, so it's kind of like a little giveaway. If you see this guy's positive and this guy's negative, that means both of these have to be negative. Okay, this is just one of those. It's brand new for you, so don't worry. We're going to do a lot of examples. Okay, let's go to the next one here. Okay, we've got 20 now. Notice we've got negative 20 here. Okay, so we need to find the factors of 20, and out of those factors, they need to add to negative 8. Okay, so what I do is I know I've got to create a negative 20 here. Okay, well, how do you create negative 20? Only way to create a negative number is if one of them is positive, okay, and then one's negative. Okay, that's just kind of an idea here a little bit. So let's start creating our factors here. Okay, well, I've got 1 and 20. I've got 2 and 10. If I keep going, I'll get 4 and 5. Okay, and I can keep going out of this. Okay, after this, you're going to start repeating. So let's start looking here. Well, if I just start adding, okay, just positive numbers, notice I'm never going to get to negative 8. That obviously makes sense. So we got to kind of use some process of deduction here. It's like, is there any way in a combination of using these right here, can one of these factors ever equal to this negative 8? Well, negative 1 plus 20, nope, that's not going to work. How about 1 minus 20? That's not going to work. When we go to this next one, well, 2 plus 10 doesn't work, okay? Right here, right? Let's see, 2 plus 10, no. Well, how about negative 2 plus 10? Well, negative 2 plus 10 gives me a positive 8, so that doesn't work. Well, how about this one? How about 2 minus 10? Well, that does give me my negative 8. So there's my guy right there. And there's my factors. That's going to be positive 2 minus 10, which notice that's a positive 2 and negative 10. I can come in here and just write this as y plus 2, and then go ahead and split up the y minus 10. And there's our factored form. Okay? Except we're going to do a lot of them. So here we go. Let's do another one here. We got y squared plus 10y plus 16. Hey, good news on this one is, guess what? Look, you've got all positives. So you don't have to worry about doing that positive negative thing. So let's come in here. We need to find the factors of this guy. Okay, so we're looking for factors of 16. That those factors of 16 will also sum together and create 10. So starting off, 1 and 16. Then we got 2 and 8. And then we got 4 times 4. And like I said, sometimes you can go pretty far with this. Okay? But notice right here, 2 times 8 equals 16. Okay? But then 2 plus 8 equals 10. There we go. We got it right there. And being that we have a leading coefficient of 1, okay, I can go ahead and write both my parentheses and do y in both of them. And then I can go and have the plus 2 in one, and then I can go and have the plus 8 in the other. And the reason this works out, you can always go back and check, and I haven't shown you this yet. I'm doing it in blue. Okay, come back in here, and you can FOIL this back out. Okay, so notice you're going to get y squared plus 8y plus 2y plus 16, and whenever you combine like terms, you get y squared plus 10y plus 16. And it works out great. Okay, so there's kind of a simple way to check yourself. This always works. Okay, so if you're worried, go back and check yourself. So 2 factor a squared plus bx plus c, if possible. Find the pair of integer factors of c, this guy right here, whose sum is b. This is the procedure we've been doing, okay? If c is positive, now here's where it's going to give you some little hints. If c is positive, then both factors must have the same sign. Okay, if this guy right here is positive, both have to have the same sign. Both will be positive if b is positive. For example, x squared plus 5x, x squared plus 5x plus 4 equals x plus 4, x plus 1. Notice, because this is positive. Notice both will be negative if b is negative. Okay, we just saw this as an example. Okay, let's continue on. If c is negative, then one factor must be positive and the other one negative, and we saw an example of that too. Notice if this guy's negative right here, okay, you may have one that's positive, you're going to have one that's negative, or vice versa. Okay, just depends. Okay, it really does depend. Okay, and you're kind of looking at this guy as well. Okay, but let this be the major kind of like hint factor right there. Let's do another one here. Completely factor each trinomial by first factoring out the GCF in the form of the common factor. Notice this is not in the form that we're used to. Okay, but let's look very carefully at this and notice, okay, that we have a GCF. Okay, if we look through here, if I started doing the prime factorization of all these, okay, which is why I said you really need to learn your multiplication table, because eventually these will just pop out at you. Okay, notice I could pull out a 5, and I could also pull out an x in each one of these. So my GCF, okay, is 5x. So let me go ahead and divide every single one of these by 5x real fast. Okay, when we do the first one, now as I do this, watch what I'm going to do. I'm going to pull this 5x and keep it on the outside here, okay, because I'm going to need that. This is, when you factor something out, it's still a number you're going to need to use, because when you start distributing back, you're going to need that number to put back in. So notice here, the 5's reduce out, and then I'm left with just an x squared. Okay, we can turn that to an x squared. I have a subtraction, and then here, notice these are going to reduce out, and that's going to be left with 3, and then I'll be left with just an x to the 1. So that's going to be just 3x. And then here, that's just going to be reduced out completely to a 2. So I got this plus 2 here. And there we go. Notice this part is now factored. Now we can kind of keep going. We can look at this guy on the inside here. Can he be factored? So with a leading coefficient of 1, I'm looking for factors of 2 that also add to 3. And if we look, we've got 1 and 2 right off the bat. 1 and 2 equal 3, but notice this is a negative number. And remember what it said. If this guy's positive, then our signs have to be the same. But if I throw a negative on both of these right now, -1 minus 2 will give me a -3. And since I'm dealing with x squared, my factored form of this guy can be 5x. Put down my 2 parentheses now. Now I can just throw my x in there twice. And these are both negative, so I've got -1 and -2. And that would be my factored form. And you could also go back and check this, which is why you had practices that do this. Come in here, FOIL this guy, and then for the final part, FOIL the 5x back in, and you would get back to your original equation. Let's look at one more little note they're giving us here. Alright, when factoring polynomials, always look for a common monomial factor first, okay, right there. Then if there's one, remember to include this common monomial factor as part of the answer. Not all polynomials are factor. For example, no matter what combination is tried, x squared plus 3x plus 4 does not have 2 binomial factors with integer coefficients. There are no factors of 4 that will add to 3. We say that a polynomial is not factorable. A polynomial is not factorable if it cannot be factored as a product of 2 polynomials with integer coefficients. Okay? Basically, if you can't find anything that multiplies together and then adds to b, it's not factorable. Okay, don't start trying to look for it. We're going to see techniques later on that make them factorable, but for right now, in your space, in your world, it wouldn't be factorable.